everyone, we're going to find the interval of convergence of our power series given. Here we're going to use the ratio test and look at the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n, and get our limit and force it to be less than 1. So let's fill everything in. We're going to get the limit as n approaches infinity of the absolute value of negative 1 to the power of n plus 1 times 2x minus 3 to the power of n plus 1, all divided by 2n plus 3. Okay, so that's 2n plus 1 plus 1. All right. Now we're dividing by a sub n, which is the same as multiplying by the reciprocal. So we're going to have 2n plus 1 divided by negative 1 to the power of n times 2n minus 3 to the 2x minus 3 to the power of n. All right, let's group all this together to help us simplify. So we have the limit as n approaches infinity of absolute value, and let's do our negative ones here. So we have negative 1 to the nth times negative 1 divided by negative 1 to the power of n. Now let's do our x's. Our x's are going to be 2x minus 3 to the power of n times 2x minus 3 divided by 2x minus 3 to the power of n. Now let's do, what are we missing? These two. And then we just have 2n plus 1 divided by 2n plus 3. All right. So let's cancel things out. These cancel out. And these cancel. These two cancel out. So basically, when you take the limit of this is just going to equal 1. So we have the limit as n approaches infinity of absolute value of negative 1 times 2x minus 3, and this is just going to go to 1. So the same degree here. So this is just times 1. Now the absolute value of negative 1 is just 1. So basically our limit equals 2x minus 3. That's the absolute value of that, and we're forcing this to be less than 1. All right, so to just find the interval, we're going to use our definition of absolute value. Right, this is 2x minus 3 is less than 1, but greater than negative 1. If you add, let's do that. We're going to add 3 to both sides. That's going to give me 2 is less than 2x is less than 4. And then we're going to divide everything by 2. So I'll do that in the next slide. We're running out of room. So we're going to get 2 is, we had 2 is less than 2x is less than 4. Divide everything by 2. You're going to get 1 is less than x is less than 2. So basically, this is your interval that we are looking at. We're going to test our endpoints to see if they're convergent or not. So at x equals 1, we're going to have the sum of n equals 1 to infinity of 1 divided by 2n plus 1. Now, using our limit comparison test, let's compare it to, let's call it b sub n equals 1 divided by 2n. This is your divergent harmonic series. So this is divergent. So if we get a c that's greater than 0 when we use the limit comparison test, that means both series will diverge. So let's use the limit comparison test. That's going to be the limit as n approaches infinity of a sub n, which is this one. So we have 1 divided by 2n plus 1 divided by b sub n, which is 1 divided by 2n. Now this is going to equal the limit as n approaches infinity of 2n divided by 2n plus 1. So this equals 1. All right, so c is equal to 1, which is greater than 0. That means they both behave alike. So since our b sub n was divergent, so is our a sub n. So our series is divergent here. Divergent. That's just going to, I can't spell. That's just going to tell us when we write the interval, we're going to have 1 comma. And now we're going to determine if this 2 is closed or open. So right now we have open interval here because at x equals 1, it's divergent. Now let's check x equals 2. So at x equals 2, we're going to get the sum from n equals 1 to infinity of negative 1 to the power of n divided by 2n plus 1. Now, let's see what happens. This is going to be positive. The limit of, we're going to have b sub n equal 1 divided by 2n plus 1. So our limit as n approaches infinity of 1 divided by 2n plus 1 does equal 0. And since 2n plus 3 is greater than 2n plus 1, that means 1 divided by 2n plus 3 is less than 1 divided by 2n plus 1. So that means it is decreasing. So it satisfies both conditions 1 and 2. Therefore, let's see, why did I put that there? All right. So that just means this is convergent at x equals 2. So your interval of convergence is, again, I have problems spelling. Your interval of convergence is going to happen at, we started with negative 1, or was it 1? It was 1, comma, and then at 2, it was convergent, so it can equal the 2 as well. And that's your answer. Thank you. Have a nice day. Bye-bye.